Here we want to factor by grouping. We have xy plus 2x plus 2. All right, so the grouping method works like this. Oftentimes, you might have to rearrange it, but usually you just look at the first two and the last two terms and look at these by themselves. And out of each of these groups, you factor the GCF out of each one. So factor the GCF out of each group. We call those little things groups. Okay, so what do you think? Here we have xy plus y. Ask yourself, what's the GCF there? I'm thinking the GCF is y. GCF is y in this one. How about the second group? We have 2x and 2. GCF in that one is 1. GCF here, sorry, not 1, 2. Okay, so let's factor out a y from the first group. So y comes out, leaving us with x plus 1. Right? So here, remember, when you factor the whole variable out and there's nothing left, there always is at least something left because there's a hidden 1 hanging out in front of every variable. So when you factor out the whole variable, you're always left with the 1 behind here. Okay, same thing in the second group. Right, here we have 2x plus 2, so the GCF is a 2, all right, x plus 1. And if you've done this correctly, these leftovers should match. If grouping is going to work, these should match. These should match. So you need to know that grouping doesn't always work just because you have 4 terms. It often does when you see them in intermediate algebra, or even pre-calc, but oftentimes if you just encountered an expression with 4 terms in the real world, just out in the wild, and someone said, factor this, grouping might not work. It doesn't work on all expressions with 4 terms. Okay, so here's the deal. You have these 2 terms that match, pull them out to the front as the new GCF. Think of this as like a mega GCF, right? This comes out here as a single x plus 1. So let's do that. So I'm factoring that x plus 1 out to the front. And what's left behind? If we pull that out to the front, we have a y and a 2 left over. Y plus 2. Right, and if that's hard to see, again, you can think of it like this. Ya plus 2a, right? Well, we can factor this a out to the front, and we're left with just y plus 2. Well, this is the same, except for a, instead of a, we have x plus 1. So it's the same principle, though. And there you go. There is the factored form. All right. Let's try another one. Okay, 16x cubed minus 28x squared plus 12x minus 21. All right, well, we see 4 terms. First thing you try anytime you see 4 terms is the grouping method. So here we go. We'll group the first 2 together and the last 2 together. Okay, that's the first thing to try. It doesn't always work, but often it does. Let's see, what can we factor out of this first one? Well, let's see. 28 is 4 times 7, and 16 is 4 times 4. So I can get a 4 out of here. We also have x cubed and x squared. Remember, when you're factoring out the GCF with exponents with the same base, it's always the lowest exponent. So 4x squared. All right, and that leaves us with 4x minus 7. Remember, when we factor out, we're actually dividing each term by 4x squared. That's what we do when we factor something out to the front. Okay, so here, just to be clear, we decided that the GCF was indeed 4x. Okay, so let's look at this second term, the GCF. We have 12x and 21. Well, so we need the largest number that divides both 12 and 21. 12 is 3 times 4, 21 is 3 times 7, so I'm thinking the GCF here is 3. And there's nothing we can do with this x. That's not going to be part of the GCF. Okay, so plus 3, and we're left with 4x minus 7. And look what we have here. These match. If they don't, something has gone wrong, or grouping doesn't work. Okay, so now we take these to the front. We factor it out like a new GCF. You can also factor it out to the right. Let's do that this time. It doesn't have to factor to the so-called front or left. You can factor it over to the right side just as easily. All right, so that gives us our final answer. Let's see here. So here we factored 4x minus 7 over to the right. And what's left behind? We have a 4x squared and a 3. 4x squared plus 3. All right, give it a quick safety check. Make sure there's no other factoring we can do. Sometimes you get down to this stage and realize that you missed something, like a GCF, or maybe you can further factor whatever's left here. But it looks like in this case, we are good to go. That's as far as that's going to factor. Let's try another one. For our last example, we have 8w squared plus 7wv plus 8w minus 7v. Okay, same idea. Group the first two, group the last two, and hope for the best. Let's see what happens. In this first set, we have a GCF. Okay, well, they both have a w in it, so I'm thinking a w comes out. 8 and 7 can't do anything there. Can't do anything with this v, so I guess it's just w. Let's check out the second group of two terms. 8w plus 7v. I'm not seeing anything there. Okay, so all we can do is get a w out of the first term. What does that give? We have w, 8w plus 7v plus 8w plus 7v. And look, these match again. So it can be helpful when you get to this point to stick some parentheses around this, because now these terms underlined in green are going to be the GCF that gets factored out. Okay, I'm going to factor this around to the front out of both terms. So notice there's only one 8w plus 7v. We're factoring it out. And let's do an analogous. Let's just step aside real quick here. If we had WA plus A, and we wanted to factor out the A, what would we get? All right, let's see. The A comes out. We're left with W plus 1, right? Because anytime the whole term comes out, there's a 1 left behind to say that it was once there. Because if we were to distribute this back through, we'd want to get the same thing back. So we need to have this 1 here. That's another way of thinking of it. You can also think of it as there's a hidden 1 always in front of every variable. All right, so following this exact same structure here, I'm going to factor the 8w plus 7v to the front the same way we did with this a here. 8w plus 7v. And what's left? A w plus, remember there's a hidden 1 right here, 1. There we go. Give it a quick check, make sure that we can't factor it any further. We cannot, so that is our final factored form.